The video you are about to watch is from an old woodworking magazine that I published during the years of 2003 to approximately 2006. This was a very unique magazine. It was purely video content and it was distributed on DVDs. The magazine ran for approximately 3.5 years, and then due to financial concerns, we simply had to terminate the magazine. We moved on to other things over the last roughly 15 years. However, there has been a request to resurrect this content, so I've gone through the trouble to get the equipment, the products, everything I needed in order to bring this content back to life to share with everyone. Here on this YouTube channel, we'll be putting up approximately 100 to 120 of the original stories that appeared in that magazine. The magazine was called Woodworking at Home Magazine, and it was truly one of a kind in the world. I really hope you enjoy these videos, and please tell your friends about them.
For this time saver, we're going to be making a circle cutting jig to adapt to our router. Now, I will warn you at the start of this project that there are some dimensions that you're going to have to determine from your router. Not all routers are the same, but I think once you understand the system, it'll be very easy to adapt it to your particular router. Now, the first thing you're going to have to do is to determine the diameter of these openings, which usually accept the edge guide. And that's what we're going to use to work with our circle cutting jig. Now, to find that diameter is pretty easy. Just take a series of drill bits, working in your basic fractional sizes. For example, here's a 1/4 inch drill, and that's a little too sloppy. 3/8 inch drill, that won't fit. And a 5/16 drill fits into that opening very nicely. So I know that the rod diameter that I need is 5/16 of an inch. The next thing that you want to do is to determine the size of screw thread that is used to clamp your edge guide into these openings. Now, if you have that option with your router, you already have the bolts. But if not, you'll have to measure that opening and then go over to the hardware store and probably try a few different sizes. If you can, take your router with you to the hardware store. Now, this is an American-made router, so I would have suspected that it would have an American-made screw or a UNC screw in it. However, it's not 1/4 inch screw. It turns out it's a M6 or a 6mm screw. So I picked those up at the hardware store. I also picked up some of this 5/16 inch diameter rod at the hardware store. This stuff is only a couple of bucks a stick, and it's 36 inches long, so it gives you plenty of adjustment to cut a wide variety of different diameter circles. Now, we also need to take a couple of measurements off the router. We need to determine the spacing, the center spacing, where those two rods go into the router base, as well as the distance up from the base of the router. On this particular model router, it works out to about 3 5/16 from center to center on these two holes. And measuring up from the bottom, it works out to about 7/16 of an inch from the bottom of my router base up to the center point or the center line where those rods go in. Now, with those two measurements made, we can come up with a yoke that will join together the two rods that come out of the router. Now, we want that yoke to be large enough to be able to be fastened onto our workpiece or onto a work bench and so forth to create that pivot. Now, the size that I came up for my router was 5 1/4 inches long by 3 1/4 inches wide. And I just ripped and cross-cut that over at the table saw. The next thing I did was I very carefully transferred the hole locations as to where those rods should go through the edge of our yoke. Now I can go over to the drill press and drill out those locations with a 21/64 inch drill bit, which is a 1/64 larger than my 5/16 inch rod. Now, with the two holes drilled, we can see how this is going to work. We've got full adjustability, but unfortunately, right now our rods will slide through our block. So we have to come up with a way of clamping our block to those rods. To do that, I'll be installing some of these 1/4 20 threaded wood inserts. And we have to start out by drilling a 3/8 inch diameter hole right above the area where the rods are. Now I'm going to be using 2 screws or 2 threaded inserts on each rod, and that will give us plenty of clamping force against those rods so it can't shift. Now to do the layout, I just carried my lines over that were parallel with 2 rod holes up onto the top surface of our yoke, and I've gone in 3/4 of an inch from each edge. Now what I want to do is drill deep enough so that this hole will intersect our rod hole. Now when we drill these 4 holes, there's a good chance that we're going to throw out burrs into the 2 rod holes, so we may have to chase back through there again with that other drill bit. Now what we're going to need is a way to pivot this block. So what we want to do is drill a 1/4 inch diameter hole for our 1/4 inch pivot pin right in the center of the block. So I'll start by drawing lines from corner to corner, and then we'll drill that with a 1/4 inch drill bit. There will be times when using the jig where you won't be able to drill a 1/4 inch diameter pivot pin hole on your workpiece. Now to accommodate that, what we're going to do is plow away this material. Now what this will do is create clearance underneath our yoke where we can temporarily mount a pivot block on top of our workpiece. Now I've set mine up so that I'm going to be cutting 5/8 of an inch from the bottom surface coming up, and it's as wide as I could get, leaving a 1/2 inch between the edge of the hole for our rod and the starting point of that area that we're going to cut away. Now I just set up the stacked 8/0 head cutter on the table saw, and we can plow out that material. With all of the machining done now, I've gone through, sanded up, and taken off all the sharp edges. Now we can install our threaded inserts. This particular style of threaded insert uses an Allen wrench to drive it in. It requires a little bit of pressure still, but goes a lot easier than the screwdriver style. The rest of the jig assembles fairly easily. Start out by inserting your rods into the router base, then we'll get our yoke onto the rods. Thread those through, and we'll even up the rods so they're sticking out the same on each side of the yoke. Now I'm using thumb screws for my clamps at the yoke end. Now that may or may not be adequate enough. You may want to use an Allen head screw or even a 1/4-20 bolt in that application, depending on how strong your fingers are to apply the clamping pressure. With these thumb screws, you can only get so much torque on them to tighten them up against that rod. Now with the rods tightened up against our yoke, we should still have plenty of free movement. Now we can install our 6mm screws. Again, these are dependent upon your router. This particular router uses 6mm. We can tighten those up. And on this particular model router, there's 3 screws that can clamp against these rods. Now when tightening them, this is a die-cast aluminum base on here, and they're aluminum threads, so don't get carried away by over-tightening them. Just snug them up, that's all you need. There's not a lot of force pulling on it, and with 3 screws clamping against these rods, it doesn't take a lot of clamp pressure to hold them in securely. And that's pretty much it for the assembly. To take the jig back off, loosen up those 3 screws, slide your rods out, and store away your circle cutting jig. Using the jig is actually quite straightforward. However, it's got a couple of features that are a little bit better than most of the commercial jigs. And we'll start out first by how you create your pivot point. Now on almost all commercial circle cutting jigs for your router, they require you to drill a 1/4 inch diameter hole, or whatever size pivot pin you have, into the surface that you want to machine your circle on. Now of course we could do that in this example. However, there is another way we can do it with this particular jig. We can put on a small pivot block and fasten that to the table. Now I've sized this pivot block to fit up underneath the area that we cut away with our stacked dado head cutter, and that tucks up there nicely. But we still have to mount this onto our working surface. And a real tricky way of doing that is just to use some double-sided tape. Now this isn't your standard foam tape that you buy at your department store. This is a heavy-duty version of double-sided tape, and wood turners use it for mounting pieces on a faceplate. So it's actually very heavy-duty. But it does require that when you press it down, you hold it in position for a little while to let it really adhere nicely. So I'll peel off the backing and mount it onto our sample board here. Just position it in place and press down firmly. There is another way to mount our pivot block onto our work surface. You could use that hot melt glue, not the hot melt polyurethane, but the hot melt craft glue. And that will temporarily glue this onto the surface. But it's now just a matter of dropping our yoke over the top of it, getting our pin to line up with the hole, and there you have it. A very stable pivot point that will work great for routing out circles. Now, of course, you can do an ID circle, milling the inside diameter of a circle, or the outside diameter of a circle with this type of jig. Now, another advantage of this jig over some of the commercial units, it doesn't require you to remove the existing phenolic base. It just slides into the edge guide mounting holes, and you just tighten up your 3 screws. Loosen up the screws, pull the jig off, and you're ready to use the router on another type of operation. Another feature of this circle cutting jig is that in this configuration, I can cut a circle as small as 11 inches in diameter, or all the way up to 88 inches in diameter. And the jig only costs about $8 to build, so you really can't beat the price and the working range. When using this type of jig, you do want to watch your cutting direction. You don't want the router to self-feed as you're moving along. Some people would refer to that as climb milling. Now, in the case if we're taking a full cut or an outside diameter cut, the outside diameter on a circle, we would plunge in at this point and feed around in this direction. Now, the cutter is spinning in this rotation, so we're pulling against that cutting action. Now, if we're cutting on the inside diameter of a circle, we would feed in the opposite direction. Now, this wraps up this issue's time saver. I hope you go about building one of these. They're very economical, very universal, and very flexible with a tremendous amount of capacity. And for about $8, you really can't beat it. Thanks for watching. I'm Chris DeHut.
I sincerely hope you enjoyed watching this video. If you truly enjoyed it, please help us share this information with the rest of the communities. Please hit the subscribe button, give us a big thumbs up, and be sure to tell your friends about this channel. Thanks again for watching.